Hello there, this is Madhasan. Welcome to my channel. Today I will discuss about a Codeforces problem. The name of the problem is inversion value of permutation. So, what the problem actually says, uh, first of all, you are given t test cases, then you are given two integers, one is n and another is k. So, what is actually n and what is actually k? The n is the size of the array you have to build. Actually, you have to build a permutation of length n, and I think you all know what the word permutation means here. A permutation is an array where each element actually presents ones in that array from a range 1 to n. Okay, and what actually k represents here? K represents um, actually the number of subarrays where at least one such pair is present, where uh, let's say ij is a pair of elements. So this condition will be fulfilled, meaning that you may have one big element in the left and another small element in the right. Here that means that ij, here I always should be less than j, yeah, and pi is greater than j. That means you have a larger element in the left and a smaller element in the right, and uh, you have to find the number of you are given the number of such subarrays where at least one this case happens. Okay, so you are given the number of subarrays where at least one this condition happens exist, and that is k. Now you have to build the permutation. Okay, so I will go to the whiteboard. So what the problem actually says, let's say we build the permutation first, then we'll discuss everything else. 3 4, then 1 2, let's say here are more elements like 5 6 7. Okay, yeah, 5 6 7. Okay, so here you can see that which are the valid subarrays that have that condition. Okay, first of all, I can see that this is a valid subarray which actually contains one such pair that p of I is greater than p of j. Here I is this and j is this. So here p of I means permutation of I, that is 7, is greater than permutation of j, that is 3. Okay, this is a valid subarray. This also valid, this also will be valid, and this also will be valid. Okay, then come to the next. We can see that this is a valid, this is valid. Even you can move this towards the right, that will also contain this. So this is also valid, and this is also valid, and so on so forth. This is also valid, this is also valid, this is also valid, and this is also valid subarrays. So this much subarrays we can actually count. We will show an example from here to understand it better. Here there is a permutation 3142. We will calculate that whether we get 5 or not. Okay, 3142. So 3 1, then 4, then 2. Is it this? Yes, this. Okay, so here we can see that this is a valid subarray, this is also a valid, this will also be a valid subarray. Okay, then come to the next, and this is a valid survey, then this will be a valid survey. This is also a valid survey, but we have taken this one, so we won't take much. So here 1 2 3 4 5 5 such surveys where the condition holds, means there contains at least one pair where p of I is greater than p of j, and the answer is 5 here also. Okay, so we don't need to calculate the number of surveys such that this condition holds as 5. Rather, we will give the answer and we have to build this foundation. Okay, so how can actually do that? Here you can see one constraint, that is n is less than equals to 30. That means we can actually run a loop of O of n to the power 4 or more. Okay, uh, one thing to notice that you have to you have given the number of such surveys where the condition holds, but if I say you what are the total number of surveys uh, that can be possible to make from this array, you don't need to have to follow any type of conditions. Just say the number of total surveys that can be formed using this array. What is the answer? The answer should be n into n minus 1 by why. uh, let's say you have an array like this, 3 1 4 2 3 1 4 2. So yeah, this is array, this is a valid server, this is also a valid server, and this is also a valid server. So 1 2 3 4, then this is valid server, this is valid server, and this is valid server. 1 2 3, then this is valid server, this is also valid server. 1 2, and this is also valid server. So that is 4 plus 3 plus 2 plus 1. Sorry, n into n plus 1. Okay. Oh yeah, here one thing to notice that here how many type of surveys you can actually take. Here the minimum length of one survey is just 2, but we have taken here once also, so we cannot actually take that. Keep this as minus. Why it is correct, I will now show you. So we cannot take 4 plus 3 plus 2 plus 1, because we cannot take this one. So there are 1 2 3, then 2, then 1, then 0. So that is 3 plus 2 plus 1. So what is that? The first uh, the first one, the last one divided by 2 into the number of elements, that is 3. So what actually this represents? 3 plus 1 equals to 4. That represents the number of elements, that is n, into 3 is n minus 1 by 2. So this number of elements that can be formed, and this number of subarrays that can be formed from this array, from an array which length is actually n. So remember this, that is the total number of subarrays that can be formed. Okay, so now we are given that here are k such subarrays where the condition follows. So what will be then this represents? Let's say we consider it as total. So consider this as total. So what will be total minus k? that is the number of subarrays where the condition doesn't follows, meaning that there is no such pair present where p of I is greater than p of j. That means the array should be like this, increasing order. That means there are no such pair in that array such that p of I is greater than p of j. So that will be just normal increasing array. So the number of normal increasing array that should be present is total minus k. Okay. Then if we somehow calculate the let's say we have now okay. One, wait a moment. uh, so how actually can you do that? You are given the total number of subarrays, you know, actually from that formula, n into n minus 1 divided by 2. Then you are given that k. So there are, let's say, consider this as x. So you have to make a array or make a permutation where the number of arrays where contains no such condition. That means the array should be strictly increasing. Okay, so you have to form a permutation now where the number of elements, where the number of subarray that are strictly increasing, that is x. Okay, then you can say that we have simply calculated total and we are given k. So let's say it has found as 3. So why not we just write 3. um, let's say 1 2 is an increasing, then we can write 5 6 is also increasing, then we can write 7 8. Why not? This is a valid answer. First of all, let's say we write the remaining ones 1 2. Let's say don't write this, we will write this 1 2, then it's 3 4, then 5 6. Okay, there are three such increasing arrays. Okay, is it valid? In this case, yeah, but if we write like this 1 2 3, then 4 5 6, then 7 8 and 9, in this case what will happen? Here are three such arrays, three such sub arrays which are strictly increasing, which array are strictly increasing. But here we can see that this is also strictly increasing, 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 this is also, so we are skipping those things in calculating. So when we have found that what is the number of arrays that has to be, what is the number of subarrays that has just only increasing elements, then we cannot simply do this thing. Rather we need to think much deeper. And how we can actually do that? We can actually solve this with the help of dp. So let's say what the dp statement will actually say as, let's say dp of x, dp of, let's say ax, don't write it as ax, let's say we consider it axis. Okay, now we can say dp of x. What the dp of x actually represent? This will actually give us the number of elements, let's say okay, I will first write it 2 and it's 3. This dp will give us that the number of elements in the array that are increasing and the number of elements that are increasing, meaning 1 2 means we can write it as 4 5, then 3 means 1 2 3, likewise. So dp of x, if dp of x give us this type of answer, then the array will look like this, where two elements are increasing, then the three elements are increasing. We cannot write this like this, that 1 2 then 3 4 5, because 1 2 are strictly increasing, then 3 4 5 are also strictly increasing, but this is also strictly increasing, this is also strictly increasing, this is also strictly increasing, but that is not present in the array. So we have to write in this way. We will show it later how we can write in this way. So if dp of x gives us this such answer, that will be our permutation. It can also be a single element like 4. If it gives 4, that means we have to write a array like this, 3 1 2 3 4. That will be a permutation. Okay, if it gives an array like this, 1, sorry, not 1, let's say 4 2 then 3, then what will happen? 6 7 8 9 4 5 then 1 2 3. You can see that here the first 4 elements are increasing, then next 2 are increasing, then next 3 are increasing, like this way. So what the dp will give us, let's say in such way we will put an x and it will actually give us uh, the solution actually, that 4 2 3. If we have known this, then we can easily simply form that permutation. So if we put an x in dp, that will simply give us the solution, that like this, in this way. Okay, then if we given that xx, that will give such way, let's say it has given us 2 3, then obviously this will be a valid permutation. Okay, in such way we will do that. Okay, so how can actually we do that? First of all, as we have constants of n is till 30, so what will be the maximum xx possible? Okay, first of all, the total number of subarrays that can be maximum possible as 900 by 2, that is actually 450 actually. I will take till 1000, no problem to take till 1000. Okay, so first of all we will take a vector of dp's, where dp from 1 to 1000 will be saved, and that will be saved in such way. So vector of vector, why I have taken this, for this one will store just x and another will store a vector like this. Okay, so we will take a vector of vector dp whose size is 1000. Now say me one thing. Okay, let's say uh, what, let's say one thing, let 1 2 3 4 you are given this array. So what is the number of such subarrays where all elements are strictly increasing? That is obviously n into n minus 1 by 2, because all possible subarrays here will be strictly increasing. So for we will run a loop from 1 to 30, and what then dp of, let's say now we are at 2, then 2 will give us what, 2 by 2 and 1. So 2 by 2 and sorry, 2 into 2 minus 1, that is 1 1. Okay, that is giving for let's say 3, that will give us what, 3 minus 2 2, 2 into 2 kata, dp of 3, that is 2. Am I saying this correct? Okay, wait a moment, we'll see dp of let's say we were at 1 2, now we are at 3. uh, Sorry, what I am writing, mistake, a big mistake, sorry, I will write it again. Actually, I have meant this, that if we are given this permutation, then what will be the number of such subarrays where every element is strictly increasing, and that the solution is this. Okay, then we can simply write as dp of, let's say if we put 4 here, then 4 into 3 by 2, what is that, 6. dp of 6 should simply be an area of 4, because here are 6 such subarrays which can be formed, and every subarray the elements are strictly increasing. So if someone gives the k as 6, not k, actually the xx equals to 6, then what will actually we will give actually 4. Then what that 4 means, that 4 means we will form an array where 4 elements are strictly increasing and nothing else. Okay, so that will be the answer. Why 6? You can see this one is strictly increasing, this one is strictly increasing, and this one is strictly increasing. 3, then 4, then 5, and then 6. Okay, so if anyone gives 6, if anyone inputs 6, then it will show as the output 4. That means we have to just form 4 such elements in increasing order and nothing else. Okay, so what will be for 5? For 5, that will be 5 to 4, my 2, so 2 2 will be cancelled out, so 10. So dp of 10 will be 5. In such way we will form from 1 to till 30, and we will actually store the values of dp. Okay, so initially the dp was actually all the values, sorry, initially there were no values in the dp. Now we know actually the dp of, let's say what, if we put 1, then 0, so we know now the dp 0. We know if we put the value of 2, then what will happen, 2 2 minus 1 by 2, that will 1. So we know actually dp of 1 also, that will give us 2. Okay, why this is a correct answer? Let's say if someone gives input 1, then that will show us output like this. So if we form a 2 element increasing array, and it has obviously one such subarray where the number of xx is equals to 1. And what is the number of xx? Number of xx is the number of such subarrays where all elements are strictly increasing. So that will we get, then if we put 3 here, then what will we get, 3 into 2 by 2. So dp of 3, that will give us this, So for 4 that is dp of 6, and what is dp of 10, that is simply this, we have found it. Okay, so in this way we can actually know till 30, and 30 will give us what, 30 into 29 by 2, that is 29 into 15. So we can actually know dp of 29 into 15. We will know these dps. Here are 30 dps which actually we know, but this is up to this. Okay, then we have to actually calculate the rest of the dps. So let's say we have to calculate dp of 14. Okay, then how can I actually calculate dp of 14? Okay, another thing I want to say you that we will actually also maintain a best sum array. Let's say we will actually also I will say why I am using this best sum array. uh, so what will it actually represent? Base sum actually means, let's say we have an answer like this. Let's say here are all one element answer. Let's say I have an answer like this, 2 2 let's say 6. Okay, this is an answer. So what is the sum? 6 plus 2 plus 2, 8 plus 2 is equals to 10. So with 10 elements we can form a valid answer of, let's say, dp of something. Okay, but if we have like this, um, 6, let's say if we can form uh, a lesser than this, like we have 2 and let's say uh, nah, let's say 7. Okay, then 2 plus 7 equals to 9. So if we form somehow this, and that is a valid answer, so will we take these or will we take this? We will take actually this, because here the number of elements is lesser than the number of elements of this. So it is the sorry the dp and actually form in lesser number of elements, and that is actually uh, more reliable for the next. Let's say I have a big array, let's say 2 4 7, and let's say I have number of elements as 10, but it will be a valid answer, but it is actually crossing the number of elements. Let's say here are 4 plus 2 equals to 6, 6 plus 7 equals to 13. So the number of element is crossing the number of n, and that cannot be a valid. So we will try uh, to calculate the value of dp so that the base sum is as minimum as possible. Okay, so base sum for all of these should be as it is. Base sum of 10 should be 5. I will write base sum also. Let's say we will write is bs of 10 is 5, bs of 6 is 4, bs of, let's say, so on so forth till, and here under this we will calculate till bs of 29 into 15, that is what, 30. So we have actually stored all the bs values also. So now we have to calculate dp of 40. Let's say we have these dps and these bs means base sums. Okay, now we will actually calculate, let's say, dp of 40. So how can we do that? We will iterate from 1 till 13. So dp of 14 is nothing but, let's say we have an x. So we have to actually know dp of x, and we actually need to know dp of 14 minus x. Let's say dp of x that has given an answer like this, 2 3, let's and dp of 14 minus x that we have calculated before, because as we are iterating from 1 to n into n minus 1 by 2, we have actually calculated, has calculated this and has calculated this, and we will not never come to this element back again. So we know the best possible answer of x, we know the best possible answer for 14 minus x. So let's say the best possible answer here is 2 3, and the best possible answer here is for, let's say, that is 2 4. So then what will be the dp of 14? Dp of 14 will be simply 2 3 comma 2 4. Okay, okay. So let's say we will iterate then 1 to 13, and every time, let's say, we are at 1, then we will calculate, we will know, we actually have known the value of dp1 and dp of 13. Then we will simply merge them. But here many values can be possible. 113 can be possible, 212 can be possible, 311 can be possible. Which will we take? We will take that, after which we merging them, we get the least best sum value. Let's say after adding these two, what is the base sum of dp now? The base sum of 14 now, that is 3 plus 2, 5 plus 2, 7, 7 plus 4, 11. Let's say we have found another x where dp of x is giving us just 3, and another 14 minus x that is giving us the answer 5. So after merging that, we are getting an array like this, and what is the sum of this? 5 plus 3 goes to 8. So instead of taking this and this, will we should be taken we should be taking this. Okay, so actually we will calculate from 1 to 13 and see which gives us the best sum answer. Best sum means which is giving us the best bs. So which that one that is giving us the best bs, we will actually take them and as an answer. Let's say here 35 has given us the best answer, so we will put 35 here, and dp of 14 will be now 35. In such way, we will calculate actually all the dp's from 1 till n into n minus 1 divided by 2. Okay. Now let's say, okay, n into n minus 1 divided by 2. Now yes, now if we put actually we know dp of on till n into n minus 1 divided by 2. Now if we want to know dp of xx, we can simply do that in O of 1. We can actually simply do that in O of 1 and find the value of dp of xx. And now the things comes, let's say the best possible dp of x that has come like this. Let's say that is 4 and let's say 5. This is the best possible dp of, sorry, x, not this is x's, and that has been come. uh, but let's say our n is actually 6. So is it possible? No, it is not possible. Why? Because here 4 plus 5, that means we actually need at least 9 elements in our permutation, but the number of elements in the permutation that is given is 6. So it cannot be possible. So in case where dp of xx, dp of xx is greater than n, in this case it is not possible. In this case we can simply output 0 or -1, whatever given in the question. But another case happens where, let's say dp of xx has come, the best dp of xx that has come, that is 4 comma 5. Let's say we have given n equals to 20. So what that means, that we actually need 4 increasing elements, then 5 increasing elements. We need nothing else, or we need no such increasing elements. So what will we do? We will simply write 4 increasing elements, then 5 increasing elements, and rest of the elements as decreasing order. So it will not hamper this, and also the number of element has been also validated. Let's say we will write like this: 1 2 uh, we will write how. Yeah, let's say here are 9 elements and we need 11 more. So what will you do? uh, Actually, yeah, we can simply write it like this: 1 2 3 4 5, then 6 7 8 9. Okay, 8 9. Should we write like this? If we put then 10 11, sorry, we will not put like 10 11. Rather we should put it like decreasing, in decreasing order. So we are remaining what, uh, 10, sorry, 1 2 3 5, 1 2 3 4 5, then 6 7 8 9. So we are okay till 9, and we have to write 10 to 20 in decreasing order. So we can write 20 first, then 19, then 18. But one thing is, 1 2 3 4 5 and 20, that is also strictly increasing, so we cannot write like this. So what will actually we do is, let's say we will yes, we need actually 9 element here. mm. So how can we actually write this like a way that these elements are strictly increasing, these elements are strictly increasing, and these are elements which is strictly decreasing, but that is not interfering with the past. Let's say if we put 10, sorry, if we put 20, then 19, then 18, then 17, then 16, that will obviously give us the right solution. But here the number of increasing element, that will increase by 1, cause 5 then 20, that will obviously increase by 1. So we will not write like this, rather we will think of a smart way. Give me some time. Okay, you can actually do the rest of the elements in increasing order. uh, One smart way is you actually remove four, five. Let's say we put six here. We have not still used five, and we will put 7, 8, 9. Let's say 10 here. Okay, then 1, 2, 3, 4, 6. Then there is 7, 8, 9, and 10. Then we will no, that will not actually cause. I think you can actually find that. I will not say how to do that. You actually try to find and calculate that. And the basic idea is, I think, clear to all of you. Is this okay? So that's is